We are going to use the ratio test again. Now, in this question, S sub n is negative 3 to power n x to power n over square root of n plus 1. And S sub n plus 1 will be negative 3 to power n plus 1. I can just write this as n plus 2. It's n plus 1 plus 1, which is same as n plus 2. All right, plug this in the formula for ratio test. Find the limit as n approaches infinity. I'll just take the reciprocal of the second term. You may want to rearrange this, make it easier for you to know which bit to simplify with what, or alternatively, you can just simplify it. There are certain things that you can actually notice that can be simplified. So let me just rearrange it. So the limit. So I'll have negative 3 n plus 1 x to the power n plus 1 over negative 3 to the power n x to the power n multiplied by square root of n plus 1 over square root of n plus 2. Okay, this will simplify to now using indices you can simplify some of these guys. So that will be just negative 3 to power 1, then x. But now the second expression, we can write it as n plus 1 over n plus 2 to power a half. And now here what we can do is we can actually factor out negative 3x. These are constants. So absolute value of 3x, because absolute value of negative 3 is just 3. So absolute value of 3x, that will be fine. Limit. And then we have n plus 1 over n plus 2 to power a half, which will be equal to now what I'm going to do is and I can take this a half. This is one of the rules when you're finding limits of sequences or series. You can take the a half outside. So I'll just have n plus 1 over n plus 2. But then what I'm going to do is write the a half outside. And then to find the limit of what's inside this bracket, use LHR, L'Hopital's rule. So what you'll end up with is absolute value of x multiplied by 1, which is just absolute value of x. All right, absolute value of 3x, because that will just be multiplied by 1, which is just absolute value of 3x. All right, but the series converges from ratio test, right? So if whatever we have, the limit is less than 1, then the series converges. This is from ratio test. So which means that our interval of convergence will be, we can write this as that. It's the same thing. And then divide both sides by 3. You'll have negative a third x to a third. All right. And we have to check the endpoints. Okay. But now we can be able to write the radius of convergence, which is a third. But let's check the endpoints so that we can find what the interval of convergence is. So at x is equal to, all right, more space. At x is equals to negative a third, we'll have the sum from n is equals to 0 to infinity of negative 3 to power n. Plug negative a third in place of x, so negative a third to power n over square root of n plus 1, which will be now negative a third to power n multiplied by so negative a third to power n, not 2 to power n, negative a third to power n multiplied by negative a third to power n, negative 3 to power n multiplied by negative a third to power n. It's the same as negative 3 to power n multiplied by 1 over negative 3 to power n. And, you know, these guys just cancel it. So you end up with 1. So what you're going to end up with here is 1 over square root of n plus 1. All right. And we can, you can rewrite this expression using one of the rules for series. Now, if you add, there are two ways, there are two methods. One, you can use the comparison limit test. Another one you can use, let me just use the comparison limit test. All right, I'll use the comparison limit test. So use comparison limit test. So I'm going to compare this series with something that I know converges or diverges. So I'm going to compare this with 1 over square root of n. So I'll get the limit. Okay. And why did I choose this, the one the denominator? Because I know that it um, I know that it um, diverges by p-series test, right? It diverges by p-series test. So what you're going to do is find the limit of this expression, and we can simplify it as limit as n approaches infinity of square root of n over square root of n plus 1, which will be limit as n approaches infinity of n over n plus 1 to power a half, which is limit as n approaches infinity of n over n plus 1 to power a half, which is equal to 1 by LHS. So now that we have that, and they have to have the same behavior. Remember, we talked about limit comparison test. If the limit of these two series, so a sub n over b sub n is equals to c, where c is between 0 and infinity, then both of the series converge or diverge. Now, we know that this series here, from our previous knowledge, we know that this series, this series we know that that series diverges by p-series test. So we are going to make our conclusion based on that, because we know that they have to have the same behavior here. So what you're going to say is since this series diverges by p-series test, then this one here diverges by limit comparison test. Okay. All right. So let's move on to the next point. So that was at x is equals to negative a third. At x is equals to a third, let's see what happens. Our series will be given by negative 3 to power n, because I'm just plugging a third in place of x. And this will be equal to, if you simplify that, now just for information, negative 3 to power n multiplied by a third to power n, that will be, you can factorize out negative 1 multiplied by negative 3, not really, multiplied by 3 to power n multiplied by 1 over 3 to power n. And these guys will cancel. So you just end up with negative 1 to power n. So that will be negative 1 to power n over square root of n plus 1. Now, this series here converges by alternating series test. Remember alternating series test, the limit of s sub n as n approaches infinity has to be equal to 0, and then s sub n plus 1 must be less than s sub n, and it meets those conditions. So this series converges by alternating series test. Okay, so we can carry on and write our conclusion and say that has the interval of convergence is from negative a third to a third, including a third, and radius of convergence is a third, or we can just say r is equals to a third. Okay, next question. Again, it's the same thing. Find the radius of convergence, interval of convergence. So what I'm going to do is, again, use the ratio test. I'm going to use the ratio test. Start with s sub n, which is x to the power n over n factorial. S sub n plus 1 will be equal to x to the power n plus 1 over n plus 1 factorial. So, and find the limit. Use the formula for ratio test to find the limit, and find out what's going on, whether we can use that to find the interval of convergence. So plug in what s sub n plus 1 is, x to the power n plus 1 over n plus 1 divided by s sub n. All right, we can rearrange this to have these two cancel. So we'll end up with something much simpler, just x over n plus 1. And this simplifies to, we can factor out absolute value of x and just find the limit as n approaches infinity of 1 over n plus 1, which happens to be 0. So we'll end up with the absolute value of x multiplied by 0, which just be equal to 0. So what that means is the interval of convergence is negative infinity to positive infinity. And radius of convergence will just be infinity.